Alright, good afternoon, ladies and gentlemen. Do you guys know what time it is? I do. It's time for some math. Let's get to it. Okay, so we're dealing with inequalities, but to not only just graph an inequality, looks like we have to do some solving ahead of time first. Now, I know it says you can do it a lot of different ways, but the way we're going to focus on today is going to be by algebraic operations mixed with a little bit of graphing. So it's a good habit to get into once you solve this thing to represent all the possible answers, and that's going to be by a method of graphing. So how do we approach this? Well, we approach it pretty straightforwardly. What we're going to do is really kind of just assume we're going to solve this like an equation. In other words, we're still looking for that balance point, that tipping point. Now, we talked about this yesterday in class and again today in class. When you're graphing an inequality, the most important thing you need to find is kind of that point where it is quote-unquote equal, and then we make our decision whether or not we go left or right to fill in the empty spots. No, I don't. Go away. So what we're going to do is kind of just ignore this sign momentarily, pretend it's basically an equal sign, and we're going to solve just like an equation. We have x plus 3 compared to 2. Well, how do I get x by itself? Well, I have to undo this. If it's an x plus 3, we're going to go with a minus 3. And of course, if I do it to one side, property of inequality demand I do it to both. So in the end, we'll have x, and then 2 minus 3 is going to be a negative 1. Now, this sign is still going to maintain, so in the end, x plus 3 is greater than 2 is the same thing as picking x's that are bigger than negative 1. So we're going to go to a number line. Negative 1 is going to be kind of like that balancing point, that tipping point. Over here, we're getting bigger, so that's like a 0. Over here, we're getting smaller. That's like a negative 2. So now we just have to make some decisions in terms of how do I actually graph this. Well, negative 1 is where I'm going to start. I have an exclusive sign, so it's going to be an open circle. And I'm looking for numbers that are bigger than negative 1. That means I'm going to shade this away. Okay, so kind of reviewing our steps, we're going to approach these inequalities kind of like their equations. We're going to solve for that point where they would be the same, in this case negative 1. Then we'll make decisions on graphing. Open circle, closed circle, and then which way we're going to shade. So, but in the end, we're looking, if we're going to try to solve x plus 3 is greater than 2, we're looking to pick any x value that's bigger than negative 1, and that should work. You can test it too. I mean, pick an x value that's bigger than negative 1, like 15. Put it in for x. 15 plus 3 is 18. 18 is bigger than 2, so clearly we're in the right region. Allow us to continue. So again, we're going to approach this as if this is an equal sign. So 15 times x, how do we undo that? Well, we're going to divide because it's being multiplied. Of course, we'll divide on both sides. Hey, 15x divided by 15 is just an x. We have the sign in the middle is less than or equal to. 45 divided by 15 is 3. So if I want to know when 15 times x is less than or equal to 45, I have to choose x values that are going to be less than or equal to 3. So let's check this out on a number line. Okay, so we have 3 in the middle. That's going to be kind of where our balancing point is, so to speak, our starting point. To the right, we're getting bigger. To the left, we're getting smaller. So let's make some decisions about open circle and closed circle. Well, I'm seeing an inclusive sign, which means I can actually use 3. I'm looking for x's that are smaller than 3. That means I'm shading to the left because that's where they're smaller. Again, we can test it to make sure we are shading all the correct answers. Just pick a number that would be shaded, like 0. Put it right back into your equation. 15 times 0 is 0. 0 is less than or equal to 45. We're good to go. This is going to be okay. Okay, so pretend it's an equation. 4x minus 5. Let's undo the minus 5 by adding 5 to both sides first. So we have 8, and then we have 4x. Undo this by dividing. So we end up with x, in this case, less than, or I'm sorry, x's are bigger than 2. Looking at the graph, it looks like we're going to have an open circle at 2 because I see just a strict sign. And I'm looking for x's that are bigger than 2. X's that are bigger than 2 are this way. Okay, so we have 2x plus 7 is greater than or equal to 15. So let's start this by undoing. Subtract 7 first. So 2x is greater than or equal to 8. Divide by 2 to get rid of the multiplied 2. We end up with x is greater than or equal to 4. Representing this on a number line, Looks like we're going to have a... Ooh, should be a 3. We're going to have a closed circle occurring at 4, and we're looking for x's to be bigger than or equal to 4. We'll shade to the right. So 5 is bigger than x minus 1. Let's add 1 to both sides first. That'll be 6 is greater than x. So in terms of what we're trying to find, 6 is going to be our starting point. Of course, numbers getting bigger to the right, smaller to the left. Looks like we're looking for an open circle at 6 because of the exclusive sign. And we're looking for x's to be smaller than 6, which means I'm shading to the left. Alright, so we have 1.5x is less than 5.25. So that's a multiplication problem. We'll undo it by dividing. So we have x's are less than 5.25 divided by 1.5. So we have 3.5. Get out of your calculator. Okay, so to graph all the solutions that are possible, 3.5 is our starting point. 4 is to the left, 4 is to the right, 3 is to the left. Let's look at our sign. I see an exclusive sign, so we're looking at an open circle, and I want x's to be smaller than 3.5. So we're shading this way. Okay. So again, kind of really quick review here. You're going to approach these just like you would be approaching a normal equation, just solving an equation. The difference is instead of just being one answer, there's a infinite set of answers, which is why we, after we solve it, we really need to do the graphing part. The graph is really where we're showing our solutions. We're acknowledging there's more than one answer, and we're shading those instead of picking them all out. Let's take a look at number 2. So now let's put these inequalities into action. Okay, so students on the dance committee at Jefferson High School are planning a dance. They hope to make a profit of at least $150 to donate to a local animal shelter. The dance committee has decided to sell tickets for $5. They also know that the cost of DJ will be $200. So the inequality, 150 is less than or equal to 5x minus 200, can be used to calculate the profit. Explain how this inequality fits the problem situation. Well, look what they're telling you up here. Like, this is really where the work starts. They want to make a profit of at least $150. Well, at least $150 means their profit could actually be less than. Like, they'll be okay if they make $100 profit, or $20 profit, or excuse me, I misspoke. They want at least $150, but they'll be happy if they make $200, or $250, or $300. But what they're really targeting is at least $150, which means at minimum $150. On the right, we have a 5x minus 200. Well, how does this make sense? Well, they're selling tickets for $5. That's how they're making their money. So if 50 people show up, 50 people times 5 is $250. That's the amount they're going to take in. Now, that's not really true because they have to pay $200 to the DJ up front. So if they were to sell like 50 tickets, they make $250 off the tickets, but they have to take away $200 to pay the DJ, so they only really make $50. So how this makes sense? Well, this is what their target is. This is how they're actually making the money. Now, if you look at the comparison of both sides, I want this side. We want this side over here, which is actually going to be the money calculation, to be no less than 150, but hopefully more. So if you're looking at these pieces, they're explainable in the same way they're explainable for equations. So let's not lose kind of sight on that. A more kind of direct answer can we have by looking at it piece by piece. 150 is a profit target. $5 would be the cost of a ticket. X is going to be the number of students attending. And the minus 200 is the expense of the DJ. Okay, so just something to keep in mind that these things are all kind of explainable, all good inequalities, relationships. That you all should be able to kind of tell me what they're about. Okay, so solve the inequality using whatever method you want. You know, we're going to use the same method that I used on the first few problems. We're going to treat this in the same manner I treat an equation, get x by itself, and then make a decision about what kind of numbers those x's could be. So first thing I have to undo is this minus 200. I'll undo it by adding 200. Of course, if I do it to one side, I have to do it to the other. 150, so that'd be 350 less than or equal to 5x. Well, how do I undo this times 5? Hopefully you guys are way ahead of me in dividing by 5 already. So we'll end up with x being bigger than or equal to 70. Okay, so the question is, well, how can I actually represent this graphically? Well, 70 is kind of our balancing point. That's where the two things are equal. Over here, the numbers are getting bigger. Here, they're getting smaller. Looks according to my sign, I can actually take 70 to be an answer. But I need x's that are going to be bigger than that, so I'm shading this away. So in a complete sentence, explain what this means in the problem situation. Well, if we look up here, we already kind of established that x was the number of students. So what we're kind of saying is that to make the $150, well, it has to be at least 70 students at this party. So to profit $150, there has to be at least 70 students. Moving on. So we have staying sharp. We have some problems we have to deal with. I'll shrink a little bit. So we're just trying to put in these symbols. Now this is a little tougher because we have some powers. Don't fret. We know all about powers. If I see like 2 to the third power, this does not mean 2 times 3. Okay, this is bad. This is very, very bad. Don't do this. This is complete garbage. Hey, if you look at 2 to the third power, what this actually means is 2 times 2 times 2. So in other words, to read this power correctly, or to read this kind of notation correctly, you're going to multiply the base number, the big number, times itself this many times. So if I'm looking at like 5 to the fourth power, this same thing is 5 times 5 times 5 times 5. Bigger number times itself that many times. If I'm looking at x to the third power, this is x times x times x. If I'm looking at b to the second power, this is going to be b times b. Don't freak out, that's all it means. So if I'm looking at this side by side, this is just 2 times itself once, so this is just 2. 1 times itself twice, 1 times 1 is just 1. Well, hopefully you guys recognize that 2 is bigger than 1. 2 times itself twice, so 2 times 2 is 4. 2 times 2 is 4. Those are equal. 2 times itself 3 times, so 2 times 2 times 2 is 8. 3 times 3 is 9. That's bigger. 2 to the fourth power, so 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. 4 squared, 4 times 4 is also 16, so these are equal. 5 times itself, 2 times itself 5 times, so 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 5 times itself is going to be 25. So bigger. Okay? So don't freak out about powers. It's just a number times itself so many times. Very easy to kind of figure out as long as you know the notation. On the coordinate plane, sketch a line that has the x-intercept of -2, 0 and a y-intercept of 0, 6, then calculate the slope. Well, let's do this one piece at a time. So we have a point at -2, 0, which means I have to move on my x-axis first to -2, because of course points are read x comma y. So -2, 0 means go to -2 on the x and 0 on the y. So -2 on the x, 0 on the y. And then we have a y-intercept of 0, 6, which means x is 0, y is 6, x is 0, y is 6. Now we're asked to calculate the slope of this line. Okay. But luckily we already kind of have a set slope triangle for us. Please recall that the slope of any line is defined to be the change in y over the change in x, which is the same as saying that it is the rise over the run. But a very important thing is that we always read these things left to right. So if I'm looking for a slope triangle, I want to calculate my rise first, which would be 2, 4, 6, and then a run of 2, which is going to be my change in x. So if I'm looking at the slope being change in y over change in x, I'm looking this to be 6 over 2, which simplifies to 3. So my slope in this case is just 3. Alright, so we're looking at these tables and answer questions 3 and 4. Well, I'm sorry, I need to complete the tables first and then answer questions 3 and 4. So to complete these tables, I'm just going to take these values and put them into my equation. At least that's what I could do. I'm not going to do that. I'm going to do a little interpretation of these equations first. Negative x plus 4, that tells me my slope is going to be negative 1. And that tells me my y-intercept is going to be 4. My y-intercept occurs as x equals 0, which means that's 4. My slope tells me I'm losing one value each time. So that'd be 3, 2, 1, 0. Going backwards, it'd be 5, 6, 7, 8. Over here, I'll do the same kind of interpretation. I have a 0.5x plus a negative 5. That tells me that's my b value. And my slope value is going to change by half a value each time. So at 0, again, where my negative or my y-intercept will be, is that'd be a negative 5. And I'm going to increase by 0.5 each time. So that'd be negative 4.5. That'd be negative 4. Negative 3.5, negative 3. Going backwards, it'll be negative 5.5, negative 6, negative 6.5, negative 7. Okay, so now let's go ahead and talk about these questions that I filled out the table. As x increases by 1, how much does y increase in table A? Well, they're actually asking for the slope here. If slope's defined to be change in y over change in x, well, they're saying if x goes up by 1, how much is y going up by? So boom goes up 1, boom goes down 1. So the answer to my question is negative 1 value. Okay, as x increases by 1, how much does y increase in table B? Again, they're just asking for the slope. So as this goes up, how much does this go up? Again, we're talking about slope here, guys, so that's just going to be a 0.5. 0.5. Will there be a common x and y pair in the two tables? Now, this is a pretty interesting question. This is going to be pretty hard to determine. One easy way is to kind of work the table out just a little bit more and see if anything comes even close. So let's continue this. So that'd be 5, that'd be negative 1, that'd be 6, negative 2, 7, negative 3, 8, negative 4. Working these as well, we'll see that'd be 5, negative 2.5, 6, negative 2, 7, negative 1.5, 8 will be a negative 1. So if we're looking side by side, I don't think I see any values that occur the same, but that doesn't necessarily mean that there aren't any. I'm going to argue that this is going to happen. Like these should share a value at some point. So here's the reason why. I'm going to say yes, and I'm going to say because the lines are not parallel. That's what that symbol means. It means parallel. So if you think about this, this makes a lot of sense. We've talked about this a little bit already in class about the graphing aspect of things. If I'm going to graph two equations on the same grid, and I'm asking you for where they're going to be the same, well, that's a pretty obvious answer. It's going to be right here where they cross. So as long as they cross, I know that they'll be the same somewhere. In other words, they're going to share a common xy pair. So I'm not going to graph these to confirm they'll cross somewhere. I'm just going to use a little bit of logic. I know the only way they're not going to cross is if they are indeed parallel. And because they have different slopes, I know that they're not parallel, therefore they will cross. So even though I don't see a value here somewhere, I know that they're not parallel because they have different slopes, therefore they're not going to cross. Alright, so let's use the two slope triangles to answer question 5 and 6. I'll look at this. Question 5 is asking me to calculate the slope of the line using the smaller slope triangle. So again, we know slope in all cases are going to be change in y over change in x, which is the exact same thing as rise over run. So looking at the small triangle, we have this to be our change in y. If we look at our increments, that's 1, 2, 3, so they're counting by ones. So that goes up by 2. So change in y is 2. Change in x is going to be 1, 2, 3. So my slope for the first one, which should be change in y over change in x, is going to be 2 over 3. So up 2 over 3. They now want us to calculate the slope of the line using the larger slope triangle. So let's see, 1, 2, 3, 4. So change in y is 4. 1, 2, 3, 4, 5, 6. So change in x is equal to 6. So again, knowing the slope is change in y over change in x, I'm looking at 6 over 4. Now that does, excuse me, I misspoke. I should have said that it's going to be 4 over 6. So I think we can do something with that fraction, but now that's really what question 6 is about. I have the slope over here that's 2/3. And I'm comparing to the slope over on this side that is 4 over 6, and we're trying to convince them or explain how these two slopes are equal. I'll explain two different ways. The first way will be purely numeric. In other words, I know that these two fractions are actually the same fraction. If I take 4 over 6 and I cut them both in half, 4 divided by 2 is 3. 6 divided by 2, I'm sorry, 4 divided by 2 is 2. 6 divided by 2 is 3. So if I were just to simply reduce this fraction, I end up with 2/3 is equal to 2/3, which checks out. That's one way. Now, the other way is actually much simpler. I simply have to look over at this and make a simple observation. This is linear. If this is linear, that means it's a straight line, which means that the slope is constant. Which means it doesn't matter where I take the slope, it's going to be the same no matter what. In fact, I could go crazy if I was feeling crazy, and I'm feeling a little crazy right now. I could take this huge slope triangle here. So that's going to be 10. Okay. And that's going to be, let's see, 5, 10, 11, 12, 13. So if I look at these two values, I'm sorry, I had 10. This is going to be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7. Oh, wow. I lost myself. So wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if I take it there as well, we'll see that that does have the same value. So I hope this helped. If you have any comments, questions, or anything below, go ahead and tell us, ask us. Make sure you post in the comments. I'm glad you guys are watching this. If you guys are, if not, spread the word. You know, we're making these videos to help you guys out. So if you know someone who's struggling, hey, I haven't turned these videos. Like, that's a good source for them to help them out with the homework. Now, you guys have a great night. Thank you for doing your homework. I will see you guys tomorrow.